Hi everyone, it's Calculus by Christy, and in this video we're going to be finding absolute extrema of the function on the closed interval. And the reason I chose this problem for this week's video is because I gave this problem to my high school students that I teach, and almost no one could get this problem, so I think it's a good challenging problem for everyone to try. So here we're finding the absolute extrema, which means the absolute maximum and the absolute minimum of this function on the interval from 0 to pi. So the first thing you need to figure out is, where could your absolute extrema occur? Well, absolute extrema can either occur at critical points or at endpoints. Well, we already know the endpoints of this interval, and the endpoints are 0 and pi. So the first thing we have to find are our critical points, and critical points occur where the derivative equals 0 or where the derivative does not exist. So that's going to be our first step to this problem. We have to find the derivative. So let's find y prime. And we have 7e to the x times sine of x, which means we have to use the product rule because we have a product of two functions. So this would be 7e to the x times sine of x plus 7e to the x cosine of x. And if you'd like to watch a video that I've made about the product rule to practice that a little more, click here to see that video. So as I mentioned, critical points is a possible place where you can find absolute extrema. And critical points occur where the derivative equals 0 and where the derivative does not exist. Well, I will tell you that this derivative right here that has sines and cosines and e to the x, it would exist everywhere on this domain from 0 to pi because there's no restrictions. So my only critical points are going to be where 7e to the x sine of x plus 7e to the x cosine of x is equal to 0. And this could be pretty challenging to solve for a lot of students. I tell my calculus students the hardest part of calculus is algebra, because solving an equation like this is a challenge for a lot of my students. So a couple key things here. The first thing I would do is I would factor out a greatest common factor of 7e to the x, since I noticed that both of the terms have this in common. Then I see that the product of 7e to the x times sine of x plus cosine x is equal to 0. So either 7e to the x equals 0 or sine of x plus cosine of x is equal to 0. So to solve the equation on the left, when does 7e to the x equal 0? Well, that would have no solution, because even if I plugged in 0, e to the 0 would give me 1, so I can never get 0 if I'm trying to solve the equation 7e to the x. Now for sine of x plus cosine x. Well, there's multiple ways of solving this, but I think the best way is to try to get this to turn into one trig function rather than two trig functions of sine and cosine. So to do this, I'm going to subtract over the cosine of x. And then here's my trick. I'm going to divide both sides by cosine of x, and I'll show you how that will be helpful to us. If I divide both sides by cosine of x, I get sine divided by cosine, which if you remember your trig functions, this would give me tangent of x equals negative cosine over cosine would be negative 1. And this is way more helpful, for me at least, because I reduced it down to one trig function, only tangent rather than having sine and cosine. So back up to the interval in this problem. Well, the interval is from 0 to pi, so I am looking only from 0 radians to pi radians. That means I'm only looking in quadrants 1 and 2 to find where tangent is negative 1. And you know what? That would end up being in quadrant 2, because tangent would always be positive in quadrant 1. Well, in order to make the ratio of opposite over adjacent be equal to negative 1, which is tangent, I would have to have a 45, 45, 90 triangle. Because the sides of the 45, 45, 90 are x, x, and x root 2, or what I like to call 1, 1, and 1 root 2. Well, since I'm moving to the left, that's going to be negative 1, and you can see that if I did from the reference angle of 45 degrees, opposite over adjacent, I would get 1 divided by negative 1, which would simplify to negative 1. So the only thing is I need to just put that angle in radians. So from here to here, with a reference angle of 45, in radians would be 3 pi over 4. And it looks like that is my only critical value that I will have. So now I'm going to take that critical value and the endpoints, and I'm going to make a table. And my table is going to be an XY table. And for the values of X, I'm going to plug in my endpoints, which were 0 and pi, and then also any critical points I found, which was only 3 pi over 4. And it's coming up with that 3 pi over 4 that gave a lot of my students a challenge. And by the way, if you're finding this video helpful so far, make sure to subscribe if you haven't subscribed already so that you can see weekly calculus videos as they are posted. So we are now going to take these x values and plug them into the original function y, because I want to know the absolute maximum and minimum of that original function. So if I plug in a y value, or if I plug in an x value of 0 into my original y function, I would have this, and since the sign of 0 is 0, that would come out to be 0. Next, I will plug in my 3 pi over 4. Whoops, I forgot the e. Let's back up. Erase this. All right, 7e to the x, which is 3 pi over 4, times sine of 3 pi over 4. And if I don't know what e to the 3 pi over 4 is, which I definitely do not, I just keep that as is, 7e to the 3 pi over 4. But then sine of 3 pi over 4, I can come back down to the picture that I drew, which is really nice to have already down here. So the sine, which is the ratio of opposite over hypotenuse from this reference angle, I can see would be 1 divided by square root of 2. So I'm just going to times 1 divided by the square root of 2. And I'm just going to leave it like that because that would give me some decimal that I don't know if I don't have access to my calculator. And now for the last one, plugging in pi for all of my x values. And once again, if I go straight to the trig function and evaluate sine of pi, that would be 0, so I know that this equals 0. Okay, so now to write out my absolute extrema, well, I have values of 0, and then this value is some positive value. So I know that that's where my absolute maximum is going to occur because I've got two values of 0, which are smaller than the positive value. And now I simply need to write out my answer, and I write 2 sentences to show that. And that is how to find the absolute extrema of this function, which again gave a lot of my students a really good challenge. If you found this video to be helpful to you, please make sure to subscribe so that you can see future videos and be notified of those future calculus videos that are being posted, and give it a like and comment below about any questions you have or any comments, because that'll be helpful to other people who also watch this video. All right, everyone, I hope you have a great rest of your day, and we will see you in the next video. Bye, everyone.